Well, in today's tutorial, I am going to talk about separation techniques used for separation of mixtures and their applications in our daily life. Well, if you are asked what is the difference between elements, compounds, and mixtures, you can't say that elements and compounds have a chemical formula while mixtures have no chemical formula. You can also say that elements and compounds are pure substances, but mixtures are impure substances. And you can lastly say that elements and compounds cannot be separated by an ordinary physical or chemical process, or mixtures can be separated by a physical process. So, in the chemical industry, we separate mixtures into its various parts by processes called separation techniques. The first separation technique we shall discuss is evaporation. This is something you must have heard before. But how is evaporation employed as a separation technique in the industry? Well, evaporation is used to separate a solid that is stable to heat from a liquid by boiling the mixture. For example, we may have sodium chloride and water to give a saline solution. Sodium chloride is table salt. So if we have a mixture of sodium chloride and water to form a solution, if I want to reverse this process, all I have to do is that I will have to heat this solution. Once I heat the solution, my water will evaporate, leaving me with my solid table salt. So this technique is used to separate a solid that does not melt or decompose on heating from a liquid. The next separation technique that we shall discuss is the separation technique called sublimation. Sublimation is a separation technique that is used to recover a solid that changes directly. A solid that changes directly to gas. A solid that changes directly to gas from other solids. The ability of a solid to change directly to gas without passing to the liquid phase is sublimation. Now, this solid that carries out sublimation is said to sublime, and solids that sublime are called sublimates in chemistry. Examples of sublimates are ammonium chloride NH4Cl. We have naphthalene. Another example is camphor. We have iodine crystals, and we also have solid CO2. So if any of these examples, for example, are in a mixture with other solids that cannot sublime, all I have to do is to heat the mixture such that the sublimate or one of the solids in the mixture will simply change directly to gas, and based on that criteria, I can separate it from other solids. And that's sublimation for you. Well, the next separation technique that we shall talk about is filtration. So, the third separation technique that I shall discuss is filtration. Now, what is filtration? Filtration is a separation technique that is used to separate an insoluble solid. Separate an insoluble solid from a liquid. An insoluble solid from a liquid with the use of a filter paper. So, in separation technique of filtration, we separate an insoluble solid from a liquid with the use of a filter paper. Now, what does it mean for a solid to be insoluble? It means that this solid does not dissolve completely in the liquid. How can I illustrate this? If I should put salt in a beaker containing water, you will notice that after dissolving the salt in water and leaving for some time, I may see no trace of salt in the water. That means that the salt has completely decomposed in water, or dissolved in water rather. Now, if I should dissolve milk in water, you will notice that after some time, I would have water which must have changed its color to the color of milk, in this case white, and also I may see little particles in water. This means that milk did not dissolve completely in water. But if, for example, I have something like iron, and I dissolve iron in water, I would notice that no matter how long I leave it, I will still see iron pellets or the dissolved iron in water just the way it was, such that my entire solution is both liquid, that is water, and solid component, iron. So it means that iron does not dissolve in water, or iron is not soluble in water. So if I want to separate an insoluble solid from a liquid, all I have to do is to pour the entire mixture into a filter paper such that the liquid gushes out but the solid is retained on the filter paper or on any other filtering device. Now the solid that is retained on the filter paper or in any other filtering device is called the residue, and the water or the liquid that is gushed out or lost in the process is called the filtrate. Do not forget that the solid recovered at the end of filtration is called the residue, and the liquid that is wasted or the liquid that is separated from the solid is called the filtrate. So that is filtration for you. Now the next separation technique that we'll talk about is something similar but different to the filtration method. It is the separating funnel method. Now what is the separating funnel method? The separating funnel method is a separation technique that is used to separate two or more immiscible liquids. The term immiscible means that these liquids cannot mix together to form a homogeneous mixture. So these two immiscible liquids are separated from each other by using what is known as a separating funnel. An example of two immiscible liquids that can be separated by the separating funnel method are kerosene and water. Have you ever dissolved kerosene in water before? Of course you have. What did you observe? When you observe that kerosene did not mix with water such that we have some things like mysteries in the mixture. And also another example, of course, is the mixture of petrol and water. And the third example is the mixture of oil and water. I'm sure you totally agree with me that these two are immiscible liquids. So to separate them, I just pour the mixture into a separating funnel, and then I have my two substances that are being separated. The next separation technique, number 5, is the separation technique called decantation. Well, decantation is a very popular separation technique, and it's also a very easy one. If I want to carry out decantation in the laboratory, all I have to do is that I have a solid and a liquid. Now, just like in filtration, this solid is an insoluble solid, and this insoluble solid is in a mixture with a liquid. To carry out decantation, I will leave the mixture for some time. Leave the mixture for some allotted time, for a time, such that on returning, the insoluble solid, being denser or heavier than the liquid, must have settled at the bottom of my container, such that I have two clear layers, a solid portion below because it is more dense than liquid, and then a liquid portion above. Let's say this is a beaker. So what I will next do is that I'll take a glass rod, alright, and let's say this is a container at the receiving end. I'll then pour this liquid that is above the solid into a container through a glass rod. By doing so, I must have separated this liquid from the solid, and that is just decantation. The next separation technique that we shall talk about is distillation. Distillation is a separation technique that is used to separate two or more miscible liquids. Yes, these liquids can mix homogeneously. So it is to separate two or more miscible liquids that have different boiling points. Of course, these two liquids have different boiling points. And that's distillation. It's a very simple technique, and it's usually used in the purification of water when it is in a mixture with another liquid that is quite miscible with water. So what happens if I have something like water plus another liquid sample X that is miscible with water? I will simply heat the mixture. Water boils at 100 degrees Celsius, for example, and in this example, My liquid S boils at 150 degrees Celsius. So to recover water from this liquid, I will simply heat this mixture, and once it gets to 100 degrees Celsius, my water evaporates, leaving me with my liquid. Now distillation, it must be noted, is different from fractional distillation. Very, very important. Distillation is different from fractional distillation. Now, what is the difference between distillation and fractional distillation? Well, I will start with the similarity. The similarity is that fractional distillation, like distillation, is also used to separate two or more miscible liquids. And these two or more miscible liquids also have different boiling points. But then, how is fractional distillation different from distillation? The difference is that in distillation, the two or more liquids have close boiling points. But fractional distillation is the choice separation method used when the two liquids in question, or the two or more liquids in question, are distillation is when they have far apart boiling points. The two liquids have far apart boiling points. But in fractional distillation, the two liquids have very close boiling points. No wonder in the crude oil industry, fractional distillation is a separation technique used for separating petroleum into its various components. Petroleum can be separated to give kerosene. It can be separated to give petrol. It can be separated to give diesel and several other substances. Well, this is actually the summary of fractional distillation of petroleum. So, in the industry, we separate petroleum because petroleum has different components that have close boiling points, different liquids with close boiling points. So, fractional distillation is the best method for separating crude oil or petroleum in the industry. The next separation technique, I haven't dwelt on that much, is crystallization. Now, what is crystallization? Well, as the name implies, crystallization is a separation technique that is used to recover solids that decompose on heating. Solids that decompose on heating, that is, solids that are unstable to heat, from a mixture of other solids. It is usually used in the separation of various salts, whereby some of them can decompose on heating while others do not decompose on heating. Now, the principle of crystallization is that crystallization always yields very pure substances, and no wonder crystallization is the best separation technique used when purity is concerned. Please take note of that important point, that crystallization is the separation technique used when purity is concerned. And so in the manufacture of sugar, it is supposed to be very pure, and also in the pharmaceutical industries which manufacture drugs, crystallization is the choice separation technique because of the purity of these manufactured substances. The next separation technique that I shall discuss is centrifugation. Centrifugation. Have you ever heard of this separation technique before? Well, probably you have. Centrifugation is a separation technique that is used to recover solids from their mixture with other substances. Solids from their mixture with other substances by spinning the mixture. Yeah, that's the key word. By spinning the mixture in a centrifuge, because as the name implies, centrifugation. So, in medicine, blood, for example, contains a lot of components like red blood cells, white blood cells, platelets, and others. So, if I want to carry out the separation of blood in the chemical industry, I will use centrifugation. So all I have to do is that, let's say for example, I have a beaker like this. Oh, should have used white. And this beaker contains whole blood. So this is my beaker, this is my container, my EDTA container that contains whole blood. How will I separate whole blood into its components? All I have to do is that I will take whole blood and put it in this container of whole blood, put it in a centrifuge and spin for some time. Now when I spin for some time, I would notice that at the end of the container being spun, my blood must have separated into at least 3 layers. A very reddish layer that contains red blood cells, another layer, something like a buffy coat, a buffy white coat that should contain white blood cells and platelets, and then I will have a straw colored layer that contains plasma. So I must have separated blood into its components. And that's just the idea of centrifugation. No wonder in your JAMB examination, the substance that is commonly used to carry out centrifugation is blood. Yeah, blood is a very common substance for the centrifugation procedure. Now moving on, the next separation technique that we shall discuss is, okay, of course, this very important one. I want you to pay close attention to this particular one because students actually find difficulty in understanding its concepts. Chromatography. Now many tutorial videos may go a long way to explain the entire concept of chromatography. But for reasons known to me and also in your best interest, I will tell you what you need to know to pass your exam. The chromatography is a separation technique that is actually used to separate substances based on a difference. Substances of migration. Substances based on a difference in their rates of migration or an adsorbent along an adsorbent. And that's chromatography. So this is the principle behind chromatography. These are separate substances that move differently along a particular medium. Chromatography, as the name implies from the etymological definition, chrome is color. So chromatography is usually used in the separation of colored substances. And choice candidates of chromatography may include amino acids, the colors, may include chlorophyll. Do you remember chlorophyll? Response for photosynthesis. And it may even include ink. So these are substances that are usually used as choice candidates to carry out the process of chromatography. And that's about everything we need to know as per the important separation techniques used in the chemical industry. Now, if you were asked which separation technique is used to separate liquids of far apart boiling points when these liquids are miscible, I'm sure you will think, and you are correct for thinking, that the answer is distillation. What about these liquids are miscible, but the boiling points of these miscible liquids are close? Then we use fractional distillation. No wonder it is employed in the petroleum industry. Do you remember that? And also, if for example you are cooking, let's say, cereal, and then you want to separate this cereal that does not dissolve in water from water, you may use a filtering material, filtering device, not so. So that is filtration. You are recovering an insoluble solid or a solid that does not dissolve from a liquid by using a filter paper. And that's all we shall take today for separation techniques. But again, another question arises. We said that mixtures are impure substances. So it is expected that after separating these mixtures, you may at least obtain some pure forms of the components separated from the mixture. Is that not so? Of course, I know you thought of that. And that will take us to what we shall use to round up our tutorial test for purity. Generally, how would you know if a substance is pure? Is it if that substance has the right color, right shape, or the right size? Probably the right taste. Well, those may be indicators and markers. But in chemistry, take these 3 criteria for knowing the test for purity of a substance. The first one is that pure substances have definite melting and boiling points. Pure substances have definite melting and boiling This holds true a lot. If I already know that water, for example, boils at 100 degrees Celsius, and then I see a sample of water that boils at 110 degrees Celsius, it therefore means that this sample of water is impure. But the water that boils at 100 degrees Celsius, which is definite boiling point of water, becomes pure. Moreover, it is important for us to know that impurities, okay, let me come to this side of the board. Impurities, boiling points, and chemistry is called stoichiometry, whereas they decrease melting point, and this in cryoscope. Some criteria is that pure substances have a definite refractive index. Pure substances have a definite refractive index when compared on literature values. Criteria for knowing the test for purity is that pure substances give one spot. Pure substances give one spot on a paper chromatograph. Pure substances give one spot on a paper chromatograph. Please take note of these three examples and keep them at heart so that you will be able to provide the answer to questions from separation techniques and tests of purity as
studyhub.com.ng for more videos.